Okay. All right, so the problem we're investigating, the change in velocity of an object measured over time tells us acceleration. How can a velocity versus time graph help us calculate acceleration? So, you got to restate that in your own words in the form of a question. Basically all it needs to be is something about how you can calculate acceleration from a velocity versus time graph. Okay, doesn't have to be complex. That's really all we're investigating here. Okay, so identifying our variables. Okay, guys, went over the graphing labs. Okay, they were generally pretty good, but I still have a few people that are not doing everything they need to do to get full marks in the design part of their lab reports. Okay, what I mean by that is this. I still have people who are not explaining their variables, okay, or they're not explaining them in enough detail. Okay, so for this one here, our variables are, okay, time, velocity, okay, and then the rest of the experiment kind of goes like this. We've got a ramp, okay, the carts, okay, we're taking one cart and we're running it down a ramp, all right. Now, just for the purpose of having 3 sets of data, I changed the angle of the ramp. That is not the manipulated variable. Okay, we're not graphing the angle of the ramp. Okay, all we did that for is so that we'll have 3 sets of data. Okay, what we're looking at here are the 2 things that are on our graph: time and velocity. Okay, those are our 2 most important variables. Okay, things that stay the same, okay, like we said, same cart, it's the same ramp, okay, same surface, all that kind of stuff. Okay, same amount of time. Well, actually, time is, spoiler alert, time's a manipulated variable. Okay, so I'll just let you know that right now. Time's the manipulated variable, and that's because everything else in the lab, the position of the cart, the velocity of the cart, all depend on time. Okay, those other 2 things are going to change. Position is going to change. Okay, how far the cart goes is going to change. How fast the cart goes is going to change. All right, so those 2 things are changing, and they're going to change more the longer I let the cart go. Okay, so the longer the experiment runs for, the further the cart's going to go, the faster the cart's going to go. Okay, that's how this experiment is going to work. Okay, so you need to make sure you explain your manipulated and responding variables. Okay, and then your controlled variables. Here's one that people don't often think of for a controlled variable. What brings the car down the ramp? Why does the cart go down the ramp? Think about that. You don't have to answer. Okay, just think about what is pulling the cart down the ramp. Okay, that force that pulls the cart down the ramp is constant throughout the entire lab. It does not change. Okay, and without it, there would be no acceleration. Okay, the cart wouldn't do anything. Okay, so think about that as a controlled variable. You're not actively controlling it, but it's also not changing either. Okay, so once you watch the video, I think you'll get the observations video. I think you'll get an idea for what the other controlled variables as well as sources of error might be. Okay, all right, questions on the design? Okay. For our hypothesis, I've already kind of got it half built for you here. Okay, so the if part needs to talk about what acceleration is. So just go with this. Tell me, if acceleration is what? Okay, give me essentially a definition of acceleration for the if part. Okay, that's what I'm looking for the if part, is a definition of acceleration. Okay, I'm just going to write that in here, guys. Okay. Okay, the and part, as always, describes the experiment. Cart's being allowed to run down a ramp, and its position and velocity are being recorded. Okay, something like that. Okay, now for the then part, okay, this is what you need to tell me. Okay, so I'm not even going to write anything because it's all here. Okay, you need to tell me in the then part 2 things. What will the velocity versus time graph look like? Okay, and how can it get you acceleration? Okay, how can you get acceleration from a velocity versus time graph? Okay, and we talked about this last week, so spoiler alert, you're going to kind of get the answer here, okay, if you're really paying attention. We're going to get a graph that looks like this. Okay, we're going to have meters per second here. We're going to have seconds on the x-axis, okay, and it's going to go up like this. All right, now we know that acceleration can be calculated using this formula. Okay, but that formula actually comes from this graph. But if I use it, I'm not using the graph. I'm just using the first point on my graph and the last point on my graph. And that's not the truest acceleration of the object. Okay, so I want you to remember where this formula came from. Okay, it's something to do with this line. Okay, maybe even something to do with this. Maybe it's some part of this formula, because remember that this formula is just a manipulation of this formula. Okay, so it's a lot like our graphing lab. The thing we're looking for is basically the same. Okay. All right, so tell me what the velocity versus time graph is going to look like. Oh, spoiler alert, Coder drew it already. Okay, and how will you be able to calculate acceleration from the graph, not using this formula? Okay, we're not using this formula. We're not plugging in our last velocity and our first velocity. We're not doing that. Okay, we're taking this. Okay, something about this will get us acceleration. All right, questions on the hypothesis? Okay, so for the procedure, you're going to watch the observations video. Okay, it's pretty short. It's just me running the carts down the ramp. Okay, pretty straightforward. Then you're going to plot a graph of the velocity versus time data. Okay, and remember how we do that. Okay, actually, you know what? I will walk you through it again. So let's have you guys watch the observations video. Okay, for right now, I'll give you about I think it's only about 6 or 7 minutes long. No, it's not even. It's only 2 minutes long. Okay, so I'm going to give you about 2 minutes, okay, to have a look at that video, and then we'll come back here and I'll walk through building the graph. Okay, and then we'll talk about the analysis and the rest of the lab. You'll probably get this lab done in class today, I would think, or pretty close to it. Okay, all right, so it is 8:50. Back here at 8:54. Okay, that gives you plenty of time to watch the observations video and make any notes about what you think sources of error and stuff might be. Okay, and of course you can watch it again and again if you want to. All right, so 8:54, we're back here and we're going over how to build the graph. Okay, so now that you've watched the observations video, okay, let's quickly talk about what you're going to need to do here in terms of plotting your graph and stuff. Okay, so you have a chart that looks like this, except it's got more rows. In fact, it has too many rows. Okay, if we're looking at yours, okay, it's got 5 rows, so you can actually delete the last 2 rows if you need to. Okay, so 4 and 5 here. If you just highlight them and then click here. Oh, sorry, never mind. Just highlight them and click delete. Right click. Sorry, right click. Delete row, delete row. So right click, delete row. Okay, because you only need 3. There's only 3 trials. Okay, so we delete those rows. We're down to our 3 trials. This stuff here is all going to get filled in after we have the graph built. Okay, so hang on here. Okay, so what I was showing you here was how to delete the rows. Okay, I was showing you how to delete the rows. So it's basically just right click in a row. If you do that, it'll ask you if you want to delete the row. Okay, obviously I don't want to delete the rows because I want to have 3 rows in here. Okay, so we're going to delete those rows 4 and 5 because you only have 3 trials worth of data, okay, to worry about. Okay, so next thing we're going to do, we are going to build the graph. Okay, we're going to build the velocity versus time graph. Okay, so same as before, put our pointer in the top left corner in cell A1, click and drag and highlight all of the data. Okay, then insert chart. Okay, and it's probably going to do this to you as well. It does not pick the right kind of chart. For some reason it figures I want a stacked column chart, which is silly. I don't. Okay, so I'm going to scroll down until I've got scatter. Okay, I want to make this a scatter plot, so I click on scatter, and that looks more like I like it. Okay, I'm going to make this a bit bigger just so it's easier to see, and I just do that by doing this. Okay, all right, then we need to make some modifications. They've got the x-axis labeled, but they've got no label on the y-axis. Okay, so I'm going to go over here to customize, to chart axis and titles, just like we did last week. Okay, the vertical axis needs a title. It's velocity in meters per second. You won't have that option. It's just because I built the graph earlier today, and so it remembers. Okay, you'll actually have to type that in. All right, so I get that. And I definitely want to change the title, okay, the overall title, because that title is silly. Okay. So I'm going to call it Need for Speed Lab. Okay, velocity versus time. Okay, that's an appropriate title. Okay, so now that I have the graph formatted correctly, now I need to go to series, make it drop down. I definitely want to apply this to all series. You can change the size of the points if you want to. I backed them off to 2 just so they were a bit smaller, and you don't have to do that. And the big thing here is we want a trend line. So down here where it says trend line, we want to check the box. And as soon as we check the box, it draws our best fit lines. Okay, now we need to have the equations, the y equals mx plus b for each one of these lines. And that's a little further down here where it says label. Right now it says none. Okay, you need to click on it and change it from none to use equation. All right, and now you can see y equals 0.612 times x plus 0.319 for run 1. Okay, for run 2, it's y equals 1.25x plus 0.438. And for run 3, y equals 1.6 plus 0.541. So you can see m is getting bigger, okay, for each line, right? This line here is run 1, the red line is run 2, the yellow line is run 3, okay, and you can see that their slopes are increasing. All right, so once you've got that, then you just click on the 3 dots, okay, copy the chart and bring it over to your lab right where it says insert graphs below. Put your cursor right there and just hit Control V and link it. Boom, done, it's in there. Okay, and you can make it a bit bigger if you want to, so it's a little bit easier to see. All right, so now we've got our graph in there. Now you can fill in the analysis. Okay, so what I'm looking for here is for you to use the equations to fill in these boxes. Okay, so the slope, okay, gotta just show me what that is. Okay, you can get it right out of the equations, but with the units. So change the word units to whatever the units for the slope are going to be. Okay, same with b. Change units to whatever the units for b are going to be. Okay, displacement, same thing. Okay, change the units to whatever the displacement for units is. I think you know what that is. Okay, and then you're going to have to calculate the displacement. That's one of the analysis questions. Okay, so here are the other 2 analysis questions. So analysis question number 1 is fill in this chart. Okay, analysis question number 2, from your data, which trial had the greatest acceleration? So just tell me, trial 1, 2, or 3. Okay, you don't have to write anything more than that, just identify which one. And then for question number 3, calculate the displacement of the car, of each car, over the entire time and show your work. Okay, so here's what I mean by that. Okay, so I've got, okay, my graph. Okay, and remember, we talked about how you calculate the displacement of an object from a velocity versus time graph, and we talked about that quite a bit and did a number of those on Friday. So if I'm looking at my blue line here, okay, remember that I've got a couple of shapes here. I've got a triangle and a rectangle. Okay, now here's the trick. Okay, in order to get the height of the triangle, okay, in order to get the height of the triangle, you will need to calculate what y equals here at the end of the experiment at 1.35? I don't have the right one open here. Yeah, 1.35. Okay, so what does y equal? Okay, you'll have to figure that out. What does y equal, okay, when x equals 1.35? Because you need that value. Okay, it's not something you can read. That point looks like it's on the line, but it's not. Okay, so you'll have to calculate what y is when x is 1.35 in order to get the height of the triangle. And remember, it's not all the way to the x-axis. What you get is what y is. When you do this calculation, you'll get this whole side. You only want this much of it, okay, to get the height of the triangle. Okay, so there's a little bit of calculating there, and you have to do that for each one of those lines. Okay, each one's going to have, obviously since they go at different speeds, okay, they're each going to have a different area. Okay, oh, sorry guys, that's really crooked, but you get the idea. All right, so you got to do that for each cart. Okay. All right, any questions on what you're doing here for the lab report? Okay, so that's what you have to do. Okay, get your graph built, which you're probably already close to. Okay, and then do the analysis here. Okay, there's nothing in this we haven't done a bunch of times already in class. All right, then you got your conclusion. Copy paste your hypothesis, same as always. Okay, explain whether it was correct or incorrect based on your data. Okay, and then 2 sources of error in the experiment and ways to fix them. Okay, I will be in and out here, guys, just checking on my own kids here throughout class today. But okay, if you got a question, I will be around for you to ask. Okay.